Thank you for joining us. In New York City at the headquarters of the United Nations on March 5th, Dr. Amanda Nichols and I, Mary Olson, made a presentation of our report, Gender and Ionizing Radiation Towards a New Research Agenda Addressing Disproportionate Harm. We were part of a panel of highly distinguished speakers, including nation-state ambassadors, and the room was full, standing room only. We are creating a recording today because no recording was made on March 5th. So thank you for joining us. Thank you for listening. And thank you for learning. Next. For decades, exposure to ionizing radiation has been understood as having a uniform impact on exposed populations. In 2006, the report Biological Effects of Ionizing Radiation, number 7, or BEER 7, provided data that revealed that women and children suffer disproportionate harm from ionizing radiation exposure compared to men. This new knowledge informed the TPNW negotiations and is reflected in the preamble and provisions on victim assistance. Next. This chart is made from data in the NAS BEER 7 report of 2006. This is a scenario based on the primary data from the lifespan study of A-bomb survivors. This study, also called LSS, was begun in 1950 during the U.S. military occupation of Japan and was taken up by the Radiation Effects Research Foundation, a joint collaboration between Japan and the USA after the end of World War II. This data originates from a crime against humanity, when Japanese cities full of people, Hiroshima and Nagasaki, were targeted by my government for nuclear destruction. I bring the data forward knowing it is wrong to use the victim's suffering, only because it is the only large radiation exposure data set that includes all ages and sexes. That doesn't make it okay. Nonetheless, this information is vital to human survival and has provided additional basis for turning away from nuclear weapons under the humanitarian impacts considerations of the TPNW. The slide shows the findings from the 2006 report. Each bar shows the rate of cancer per 100,000 adjusted for a scenario where everyone got the same radiation exposure to more clearly see age and sex as factors. So the data has been adjusted to the scenario as if all individuals were exposed to one gray. The red bars are females and the blue bars are males. The bottom shows the ages the survivors were in August 1945 when exposed to the gamma neutron burst of the A-bomb detonation. Those who were infants are grouped at the left, and on the right, the elders. Each age cohort was tracked across their lives for 60 years. Cancers were counted and recorded and counted for each group, disaggregated by sex. It is easy to see that females suffered more cancer than males in every age group, and the difference is greatest when the exposure was in childhood. Next. Here we come to our new 2024 report. It is an update on the original work, and our primary research question, whether Further research has been conducted to verify, engage, or refine the findings from the BEER7 data that shows that girls and women are at more risk of harm from ionizing radiation compared to boys and men. Next. Our report includes detailed research methodology. In our report, we cover peer-reviewed scholarly radiation research published since the 2006 BEER7 report. There are 19 additional studies included. These studies are representative sample. And adding BEER7, we now have 20 peer-reviewed sources confirming that radiation is more harmful to female bodies. We found that the current literature on radiation harm that is disaggregated by biological sex was more extensive than we initially expected, and it covers various disciplines and angles. However, few of these papers look directly at biological sex as a factor in radiation exposure outcomes. We need institutions of excellence and rising generations of researchers to take this on. Next. Next. Our key findings in the 2024 report sponsored by UNIDIR include robust evidence that radiation causes more cancer, heart disease, and stroke in women compared to men. We now have 20 peer-reviewed sources that show this information. We know that age at the time of exposure is an independent and compounding factor in assessing radiation outcomes. Some adult cancers are due to childhood exposure, which makes the adult population complex in terms of radiation risk profile. We also know that little girls, when exposed early between birth and 5 years old, are the most at risk over the course of their lifetime for developing cancer and non-cancer health consequences. Next. Why it matters. Scientific research on the humanitarian impacts of nuclear weapons improves our understanding of the differentiated health consequences of nuclear weapons. It also underscores the need for age, sex, and gender-sensitive protections, disarmament policies, and support for impacted communities. It recenters the conversation on the needs of survivors of all ages and on affected communities. It bolsters the humanitarian rationale for disarmament based on long-term, compounding, intersectional, and intergenerational health consequences of ionizing radiation. Next. So, why is sex a factor in the outcomes of radiation exposure? The short answer is that we don't yet know. What we do know is that females are at risk of developing cancer after exposure at all life stages. An early hypothesis by Dr. Rosalie Bertell suggests that a higher percentage of reproductive and radiosensitive tissue in female bodies may be one reason for this. However, this early proposal does not explain cardiovascular impacts where females are also more harmed than males. Next. Our species, like others, is a cycle that repeats through time, forming our generations. Each life stage depends on and emerges from all the others. We now know that male and female somatic phases are significantly different, and so are pictured here as separate sub-cycles, forming a pattern like an infinity symbol or a figure 8 on its side. There is a tacit assumption that reproductive cells only come into play with reproduction. In fact, these cells are present in the soma, our body, at every age. Impacts to the soma may also impact these primary elements of the next and following generations. We fool ourselves into believing that study of impacts on a, quote, adult population, often composed solely of adult males, can tell the whole story of any health consequence. The post-birth radiation data shows that children, particularly girls, are the most harmed life stage. Unless protection is centered here, then we have not protected our life cycle. We cannot continue to look at adult-only population models. If we want to fully understand the ways that radiation impacts us and the future of our species, we must create a life cycle model. This needs to be the new standard for quality radiation research and regulatory policy. Next. We actually skipped this slide in our presentation, but I bring it here to show the same data that was in the bar chart now as a graph. And in this graph, we can clearly see that the pink line females never crosses the blue line males, that radiation exposure in early life is more harmful to both females and males, and that this means that age and sex are independent and compounding factors in the outcome of radiation exposure. Next slide. Thank you very much, and we now turn to Dr. Amanda Nichols.
Thank you, Mary, and thank you again to everyone who is watching this today. In our report, we refer to the gendered impacts of nuclear weapons, and we highlight the important differences between biological sex and gender. This distinction, we feel, is a critical one to make. Biological sex refers to the binary model, female or male, where the sex is assigned at birth or by the researcher. This is the model that is currently used in scientific research focused on assessing the health consequences of ionizing radiation exposure. This model presents two key problems. First, it presumes a binary where intersex individuals, or people who are born with phenotypic ambiguity in their sex organs or chromosomal combinations other than XX or XY, are either misrepresented or not represented at all in the data set. This includes about 1.7% of the global population, which is approximately 136 million people worldwide. This absence not only points to the gaps in and limitations of current radiation research methods, but it also shows how marginalizations and exclusions are perpetuated in radiation research. Second, biological sex is often uncritically conflated with gender in data sets. We already know that different types of bodies bear the brunt of environmental and radiological hazards differently. But what often happens is that radiation researchers introduce non-biological factors without controlling or accounting for the ways that these factors are often already inherently gender biased. These include social factors like income level and access to healthcare, and environmental factors like geographic proximity to hazardous waste and more. The point is that biological sex does not exist in a vacuum. Rather, it is intersecting with notions of gender that exist in a given society at a given time. There are always external factors that inform the ways that individuals are affected by exposure to ionizing radiation, and these go beyond biological sex and other biological factors. There were several key reasons that we chose to talk about the gendered impacts of radiation exposure. First, using gender and the terms women and men signals that this research is focused exclusively on human populations to which those terms have been exclusively applied. It does not consider the effects of radiation exposure to non-human organisms, which also distinguish the biological sexes as male and female. We make this distinction because there is still much important work to be done regarding the biological and life cycle impacts of radiation exposure in non-human organisms. Second, talking about gender signals that there are both biological and social factors that inform disproportionate impact to radiation harm. This is very important because it takes seriously the ways that biological, social, and environmental factors can and often do intersect or combine to produce compounded forms of radiation harm. In other words, by using the term women, we aim to acknowledge not only biological sex, but also all of the social, cultural, and environmental factors that shape lived experiences in female bodies. Finally, we use these terms to underscore the humanitarian implications of nuclear technologies. We must remember that the impacts of ionizing radiation affect the lives of real human beings with bodies and minds who are more than just numbers in a data set. Developing a more nuanced understanding of the ways that gender informs radiation research will help us to understand the ways that compounding factors contribute to health consequences from radiation exposure. Intersectional approaches to thinking about the impacts of nuclear technologies can help us to better understand how biological factors such as sex, age, and race intersect with social factors including ethnicity, socioeconomic status, and geographical location. These factors can and often do compound to create unique forms of oppression that exacerbate the risk of negative health consequences. Intergenerational and intersectional harm are explicit in radiation exposure data. Yet despite this evidence, these harms have not been widely addressed or discussed in the context of exposure at different life stages. One of the most important questions that arises from looking at radiation impacts from an intersectional perspective, which takes seriously compounding and life cycle impacts, is the question of generational impacts of radiation harm. What this data shows us is that we need a more nuanced understanding of the effects of radiological harm. Transgenerational approaches are needed. Such an approach is necessary to better understand the long-term impacts of radiation from nuclear technologies that are present in our environments. And these approaches are applicable across species lines, so they apply to all life forms, not just to human populations. We now know that biological sex and age at time of exposure are independent and compounding factors in radiation harm. We also know that radiation outcomes are not uniform, despite the same level of exposure. Radiation causes more cancer, more heart disease, and more stroke in women over the course of the lifetime than in men who are similarly exposed. And while the percentage of reproductive tissue in a woman's body may account for higher rates of radiation-caused cancer in women, we also know that this hypothesis does not explain disproportionate cardiovascular disease from radiation in women compared to men. Because of all of this knowledge, we know that radiological protection guidelines must be upgraded and centered on those who are most harmed. If we protect those who are most at risk, we will be able to protect everyone better. With this improved understanding, it gives us a better idea of what is needed moving forward. First, engagement. We need a widespread commitment to developing effective evidence-based protection. We also need research. We need studies that address key questions like why are sex and age factors in radiation harm. Third, we also need inclusivity, research methods, and data analysis that considers intersectional and compounding factors in radiation harm. In general, more research is also needed on the intersectional and transgenerational harms of radiation exposure. Our existing hypotheses need to be tested, and we need new ideas. Here we provide a few brief examples of questions for future radiation research. One of the primary questions that we ask is, why is biological sex a factor in radiation harm? Could factors like immunosuppression, genetic markers that differ by sex, epigenetic factors, or internalized exposure be main factors in this disproportionate impact? We know that there is an evidence need for intersectional and transgenerational studies. The lifespan study contains data from the first generation only, so it does not reflect the current global population 80 years out. Another important question then is, what impacts are observed in second and third generation offspring when the parent has a known radiation exposure? For a more detailed list of questions for future research, we invite you to see Section 5 of the Agenda for Future Research in our report. In closing, we want to highlight some of the ongoing dialogue and action already happening within the TPNW and how you can get involved. There are opportunities for collaboration with the Scientific Advisory Group or on scientific research, including research that addresses the question, why does radiation harm women more, and why are children the most harmed? We encourage everyone to seek out opportunities for international cooperation and assistance in the development of capacity building and scientific exchange programs. We also invite you to consider opportunities for age and gender-sensitive research and victim assistance, and to approach this work from a perspective of meaningful inclusion of victims and survivors in all areas of policy, programs, and projects. We want to thank everyone again for watching this video, and I would also like to extend our thanks to our host at the UN meeting on March 5th, Ireland, Mexico, and the United Nations Institute for Disarmament Research. And you can download our report free of charge on the UNIDIR website by scanning the QR code here. Thank you.